Okay, here we have a question that was submitted by a student, and this one says solve the system using elimination. So elimination method or addition method are the exact same thing depending on what book you're using. Okay, so our first order of business here is we have to decide which one of the variables we're going to get rid of. And it doesn't matter, whichever one you want to get rid of is fine. Let's go ahead and get rid of the y's in this one. Now we can do that if the y's, when we add the equations together, will cancel out. So what I'm talking about is, wouldn't it be nice if we could change these numbers in front of the y into the same thing, but opposite in sign, so that they would cancel? So I would really like to have a plus 12y and a minus 12y here. Well, the way that we're going to make that happen is if we multiply the top equation by 3, that way that would give us a 12y, and if we multiplied the second equation by 4, so that would give us a negative 12y, and they would cancel out. Now we can't just multiply to one term, we have to distribute through every single term. So that would, our first equation would be negative 21x plus 12y equals negative 18. And our second equation would be 32x minus 12y equals negative 4. Now by doing that, when we add these two equations together, now our y's cancel out. And here we have a minus 21x and a plus 32x. So whenever I add those together, we will get 11x. Now those y's canceled, equals negative 18 minus 4 would be negative 22. And now to get x alone, we would have to divide both sides by 11. So we would have x equals negative 2. So there's one answer. Now we also need to know what the y value is. So I'm going to plug this x that I know back into either one of the original equations. So if I plug it back into, let's just say the first equation, that would be negative 7 times negative 2, replacing the x value with negative 2, plus 4y equals negative 6. And now simplifying and solving. So this would be a positive 14 plus 4y equals negative 6. And then subtracting 14 from both sides, we would have now 4y equals negative 20. And then finally, to get y alone, we would have to divide both sides by 4. So we would have y equals negative 5. So our answer then would look like the point negative 2 comma negative 5. That would truly be our final answer. Now we could check this to make sure that these are actually a valid point on both of those lines by plugging them back in. So here is our check. If we use, in the first equation, negative 7, but instead of x we say negative 2, plus 4 times, but instead of y we use negative 5, equals negative 6. We're going to look to see if this is a true equation. So this would be 14 minus 20 equals negative 6. 14 minus 20 would be negative 6, so this one does check. For our second equation check, we would again do the same thing, plugging in place of x the negative 2. So 8 times negative 2 minus 3 times negative 5 instead of y equals negative 1. So this would be negative 16 plus 15 would equal negative 1. Negative 16 plus 15 is in fact negative 1. So it checks in the second equation also. So that tells us that our answer truly is the point negative 2, negative 5.